In this problem, we're asked to dilate a figure by a factor of 2 centered at the origin. So how do you dilate a figure? Well, step 1, we need to write the coordinates of the pre-image. So in my pre-image, I see I, H, and G. The coordinates of I are 2, 3. Of H, I see 3, -1. And of G, I see -4, -1. Then we apply the scale factor. So you might be saying, how do I apply the scale factor? Well, a dilation makes something larger or smaller. So all we have to do is multiply each of these coordinates by the scale factor, and we will get a new set of coordinates. So my scale factor is 2. Let's go ahead and multiply by 2 and see what our new coordinates are. I prime, H prime, and G prime. Let's start with I. I is located at 2, 3. 2 times 2 is 4. 3 times 2 is 6. Now we'll go to H. 3 times 2 is 6, and -1 times 2 is -2. Do the same thing for G, and you'll get -8, -2. We may have made a math mistake, but I think we'll know as soon as we graph it. So let's take a look at what it would look like on the graph. I prime is at 4, -6, or sorry, 4, 6, that's here. H is at 6, -2, that's here. G is at -8, -2, that is here. Looking at that, I would say the shape maintains, or the shape is upheld, right? So the angles look the same as the original triangle, but you know what's changed? The length of the sides. So the shape is still intact, it's still a triangle, but it's a bigger triangle in this case because the scale factor was 2. Let's see if we're right. We got a little check mark, looks pretty good, and there's also an animation. So take a look at that animation. The figure's getting bigger. Let me see if I can find another one where the scale factor is a fraction. Here we go. And I'm not gonna graph this whole thing, but I'll just do one of the points with you for this one. So it says that the figure needs to be dilated by a factor of 1/3 centered at the origin. So if I were to dilate this by a factor of 1/3, I'd be multiplying by my scale factor 1/3. Is that going to get bigger or is that going to get smaller? The image should be getting smaller because we have a fraction that's less than 1. I'm just going to pick one of the points, point L. L looks like it's located at -6, +9. And if I were to multiply both of those by 1/3, then L prime would be located at -6 times 1/3 is -2. 9 times 1/3 is, oh, I was about to put negative, sorry, +3. So I'm going to plot L prime, and then I'm just going to click Show Solution. L prime is at -2, +3. So that is right there. I just drew a little dot on the screen. Let's click Show. You would have to also do that with the other 3 coordinates as well to get the right shape. But I'm going to just click Show Solution so you can see that we at least have that first point correct. Okay, take a look. Is this L prime located at -2, 3? It sure is. And as you can see in the animation, the shape is getting smaller. The side lengths change, the angles don't change, the angles are all intact. So typically we say it's not a congruent figure because they're not exactly the same, but it's a similar figure because the side lengths are proportional to each other. All right, now you're going to give some dilation problems a chance on your own.